Hello all, welcome back to our channel. Today we are going to discuss some important questions from geotechnical engineering, and the topic we are going to discuss today is origin of soil. So first question, which of the following type of soil is transported by gravitational force? So we know that the soil is formed by the disintegration or decomposition of rocks, and as the soil is formed or located at the place of origin, and we can say that soils are called residual soils. So residual soils, these are the soils formed at the place of origin itself. Then next comes place of origin. Okay, and the examples for residual soils are the soils formed from the rocks like granite, basalt, limestones, etc. So residual soils are the soils located at the place of origin and the soils formed from the rocks like granite, basalt, limestone are called the residual soils. Then next we are going to study transported soils. Transported soils. These are the soils get transported from its parent location to a new location. So transported soils are the soils that get moved from their parent location to the new location with the help of wind, ice, water, or by gravity. So these are called transported soil. So many these transported soils are again classified into different types of soils based on the agent that get transported. So first one is alluvial soil. Alluvial soil. These are the soils transported by the running water. Running water. Okay. Then the second one is lacustrine soil. Lacustrine soil. Here the agent is still water of lakes. So the soil deposited by the still water of lake we can call lacustrine soil. Okay, the third one is marine soil. Okay, one more thing is here. Here you have to add one more thing. The deposit of soil due to the still water of lake we can call it as warped clay. Warped clay. So alternate thin layers of silt and clay is called warped clay, or lacustrine deposits are called warped clay. So this is an previous year question. We can say warped clay is the deposits due to the still water of lake, or lacustrine deposits. Also warped clays are thin layers of silt and clay. Okay. Next is marine soil. Marine soil, these are get deposited by the sea water. Marine soil by sea water. The agent is sea water. Then next one is aeolian soil. Aeolian soil. The agent is wind. So here the example for aeolian soil is, lavas and sand dunes. Okay, so here example is sand dunes and lavas. The next one is fifth one is glacial soil. Glacial soil, this is by glaciers, either by ice or water issuing from the melting of glaciers. So glacial soils these are the soils deposited by glaciers, either by ice or water issuing from melting of glaciers. So example for glacial soil is drift, till. Okay, these are the examples for glacial soil: drift, till, and one more is outwash. Okay, these are the example for glacial soils. Then the sixth one is colluvial soil. Colluvial soil, these are due to the gravitational force. These are due to the gravitational force or by gravity. So we can call colluvial soil. So example for colluvial soil is talus. So examples are very important. So here we see residual soils and transported soils. So residual soils, we can see the residual soils at the place of origin itself. So example for residual soil is soils formed from rocks like granite, basalt, limestone, etc. Then next one is transported soils. These are the soils get transported from their parent location to a new location with the help of ice, wind, water or gravity. Then different types of soils are coming under this transported soil based on the agents that they carry. So first one is alluvial soil. The agent is running water. The lacustrine soil, this is due to still water of lakes. So waved clay, it's an example for lacustrine soil. That means lacustrine deposits are called waved clay. These are all. Another definition for waved clay is alternate thin layers of silt and clay. Alternate thin layers of silt and clay is also called waved clay. Then next is marine soil. So here the agent is sea water. Then next is aeolian soil. Wind is the agent. Example lavas and sand dunes. Next is glacial soil. Glacial soils, agent is glaciers. That is ice or water issuing from the melting of glaciers. The example is drift, till and outwash. The examples are very important. Drift, till and outwash. The next one, the last one is colluvial soil. This is due to gravity. The example is talus. Okay. So in our question, which of the following type of soil is transported by gravitational force? So here which lavas is example for aeolian soil. Talus, example for colluvial soil. Sand dunes by wind. So it is aeolian. Then drift, glacial soil. So due to gravity force we call it as colluvial soil. So here answer is talus. Talus is called colluvial soil, and colluvial soil is due to gravity or gravitational force. So answer B is the correct. Second one, the collapsible soil is associated with. So what is collapsible soil? Collapsible soils are the soils which there is a decrease in volume on addition of water. So collapsible soils are the soils in which decrease in volume takes place on addition of water. So example for collapsible soil is lavas, and this lavas is a silt deposit made by the wind. So we can say lavas is a silt deposit. Lavas is a silt deposit made by wind. So the volume of the soil decreases on addition of water. We can also say that these deposits have low density. These deposits have low density and very low bearing capacity, low density, and they have high compressibility. So these are the peculiarities of lavas. Lavas are the silt deposits by wind. They have low density, low bearing capacity and high compressibility, and the soil volume decreases on addition of water. So these are called collapsible soil. Collapsible soils are soil in which decrease in volume of soil takes place on addition of water. Example is lavas. So here the answer is lavas. Option C is the correct one. Next one is bentonite is a material obtained due to the weathering of. So here we are going to study bentonite clay. This bentonite clay have high percentage of, we can say they have high percentage of montmorillonite. Montmorillonite. So they are highly plastic. They have high shrinkage and swelling because of the presence of montmorillonite. They have they are highly plastic, high swelling and high shrinkage. And these are formed due to volcanic ash. So we can say bentonite clay, high percentage of montmorillonite. They are highly plastic, they have high shrinkage and high swelling. Then they are formed due to volcanic ash and can be used as drilling mud. So these are the points regarding bentonite clay. So here the answer will be volcanic ash. So bentonite is a material obtained due to the weathering of volcanic ash. The fourth question, loam means. We say warped clay. Isn't it? Warped clay is a combination of alternate layers of silt and clay. Isn't it? Warped clay is alternate layers of silt and clay. So loamy soil is, another name of loamy soil is garden soil. Loamy soil is also called garden soil. It is a mixture of sand, silt and clay. So loamy soil is also called garden soil and it's a mixture of sand, silt and clay. And the warped clay is alternate layers of silt and clay. So here options are sandy clay with a little silt, silty clay with a little sand, silt and clay in nearly equal proportion, silty sand with a little clay. So here the answer is option C, sand, silt and clay in nearly equal proportion. Okay, next fifth question. Laterite soils are formed by the process of. We said that the soil is formed by the disintegration of rocks or weathering of rocks. Mainly weathering takes place by two methods. First one is physical weathering and the second one is chemical weathering. Formation of soil takes place by either by physical weathering or by chemical weathering. So physical weathering, here erosion of rocks by wind, water, glaciers or alternate freezing and defreezing. These are the some reasons for physical weathering. Maybe temperature change, wedging action of ice, abrasion or penetration of plant roots. And some examples for soils formed by physical weathering is sand, gravel, or we can say coarse-grained soil. Coarse-grained soil. These are the examples for soil formed due to physical weathering. Physical weathering may be mainly due to temperature changes, wedging action of ice, abrasion or penetration of plant root. And the example is coarse-grained soil. Next comes chemical weathering. Chemical weathering is mainly due to oxidation, hydration, carbonation, solution or chemical actions of acids, alkalis in water, air, glaciers, etc. That's also another reason for chemical weathering. Chemical actions of acids, alkalis in water, air, glaciers, etc. These chemical actions are we mentioned above. So here the example is clay and silt. Here one more is there due to leaching action. So leaching action, as a result of leaching action, laterite soil is formed. laterite soil is formed. So laterite soil is formed due to leaching action, and these also all are important: physical weathering and chemical weathering. In physical weathering, temperature changes, wedging action of ice, abrasion, penetration of plant roots, these are the reasons. Example is coarse grained soil, and in case of physical weathering, soil formed retain minerals and composition. There is no change in, no chemical change, there is no change in composition. Mineral composition is not changed. In case of physical weathering, no change in mineral composition. But in case of chemical weathering, mineral composition is changed. Mineral composition get changed in case of chemical weathering. Okay, so here the answer is leaching. Laterite soils are formed by the presence of leaching action. Option A will be the correct answer. Next is residual soils are formed by, we already discussed residual soils. Residual soils are the soils formed by the at the place is located at the place of origin. So these glaciers, water, wind, these all are the agents that helps for soil to transport. So here the answer is residual soils are formed due to none of the above. Option D is the answer. So here glaciers, soil formed due to the deposition of glaciers, we can say glacial soil, wind, aeolian soil, then water. Running, if it is running water, we can say alluvial soil. Okay, seventh question. Sand particles are made of. Sand particles are made of. We have to study rock minerals and clay minerals. So what are the rock minerals? We can see rock minerals in rocks. You can see rock minerals in rocks, and the rock minerals are quartz, mica, feldspar. Okay, so clay minerals, we can see the clay minerals in clays. So the examples are montmorillonite, illite, and kaolinite. So these are the clay minerals and rock minerals. Okay, these clay minerals carry electric charges. Clay minerals carry electrical charges. It carry electrical charges. That's why they have plasticity property. Okay, so here our sand particles are made of. These kaolite, montmorillonite, illite are clay minerals. These all are clay minerals. So sand particles are made up of rock minerals. Option A is the correct answer. Then the eighth question. Clay mineral with largest shrinkage and swelling is. Okay, we learn these clay minerals, that is montmorillonite, illite, and kaolinite. Okay, these are the clay minerals. Because of their electrical charges, they have plasticity property. In case of montmorillonite, the units are attract or bonded by a weak force. Here the force between each units is weak, and that is called van der Waals force. Van der Waals force. Each units are bonded by weak van der Waals forces. So they have high shrinkage. They have high shrinkage and high swelling. They have high shrinkage and high swelling due to its weak van der Waals force. Next, in case of illite, in between each structural units, potassium ion is there. Potassium ions between structural units. So here the shrinkage and swelling is medium. Here we have see medium shrinkage and swelling. Here in each structured units we can see the potassium ions. So here the shrinkage and swelling is medium in case of elite, and next is kaolinite. We can see strong hydrogen bonding. In case of kaolinite we can see strong hydrogen bonding. So here no shrinkage, no swelling. Okay. Monomorlonite, the in between the units we can see weak van der Waals force, so high shrinkage and swelling. In case of elite, potassium ions in between the structured units, so medium shrinkage, medium swelling. In case of kaolinite, strong hydrogen bonding between structural units, so no shrinkage, no swelling. So we can see in case of swelling, shrinkage and plasticity, the order is monomorlonite, elite, kaolinite, and last rock minerals. Okay, these are the order for shrinkage, swelling and plasticity. So here we know the order. So largest shrinkage and swelling for monomorlonite, followed by elite, then kaolinite. Okay, then next question. Which of the following type of soil is transported by wind? The soil is transported by wind, which is called aeolian soil. So the answer is lacustrine soil is by the still water of lakes. Then talus is by gravitational force. Then drift, glacial soil. Drift is glacial soil. Drift till outwash all are glacial soil. The correct answer is lavos. So lavos and sand dunes are the example for aeolian soil. Option A. Next question. Chemical weathering of rocks results in coarse-grained and non-cohesive soil, fine-grained and cohesive soil, coarse-grained and cohesive soil, fine-grained and non-cohesive soil. Chemical weathering of rocks. We studied physical weathering and chemical weathering. In case of physical weathering, we said examples are coarse-grained soils, means sand, gravel, etc. Coarse-grained soil. As a result of chemical weathering, we get clay and silt and clay. So this comes under fine-grained cohesive soil. So option B is the answer, fine-grained and cohesive soil. So chemical weathering, these are fine-grained chemical weathering. Soil formed is fine-grained and soil with cohesion, that is cohesive soil. These are about chemical weathering. In case of physical weathering, coarse-grained soil, here it is soil with friction, non-cohesive, cohesionless soil or non-cohesive soil. Soil with friction, that means cohesionless soil. In case of physical weathering, cohesionless soil. Chemical weathering, cohesive soil. So fine-grained cohesive soil is chemical weathering, and coarse-grained with the non-cohesive. Here coarse-grained with the non-cohesive is due to physical weathering. Okay, next question. Physical weathering of rocks result in. We already said coarse-grained and non-cohesive. Fine-grained and cohesive is, we said, chemical weathering. Coarse-grained and cohesive soil, fine-grained and non-cohesive soil. Coarse-grained and non-cohesive soil. A is the answer for physical weathering. Next is drift and till are the soils transported by. So many times we discuss drift and till is due to glacier. For gravitational force, talus will come, wind, aeolian soil, lavos will come, then running water or by river we can say alluvial soil. The next is varved clays. We already studied varved clay. It's a mixture of sand silt clay. Mixture of sand silt clay is called loamy soil or garden soil. Sedentary deposit. Alternate thin layers of silt and clay. So it's a sedentary deposit. We can say it is a sedentary deposit. Alternate thin layers of silt and clay. So alternate thin layers of silt and clay is correct. So the actual definition for varved clay is a sedentary deposit of thin layers of silt and clay. So varved clay is sedentary deposit and it is alternate thin layers of silt and clay. So option B and C will be the correct answer. Option D is correct answer. So next time, the term soil mechanics was coined by Terzaghi. Soil mechanics was coined by Terzaghi. Then next 15th question, behavior of clay is governed by. Next topic we are going to study is force acting on the soil particles. We studied physical weathering, chemical weathering and the rock minerals, clay minerals, everything we learned. Next is force acting on the soil particle. First is gravitational force or body force. Gravitational force, or we can say body force. This is proportional to mass. Gravitational force is proportional to mass and we can say example is weight. And this gravitational force or body force is predominant in gravel and sand. Gravitational force we can also call body force. This is proportional to mass and example is weight. This gravitational force is predominantly in gravel and sand. Then next is surface force. Next type of force is surface force. This is proportional to surface area. Surface force proportional to surface area, cohesion, electrochemical force, all are under surface forces. So this is predominantly seen in clay. So clay we can see surface force and this surface force is proportional to surface area and the forces in clay is cohesion and electromagnetic force. Next is gravitation force or body force. It is directly proportional to the mass. Example is weight and it is predominantly seen in gravel and sand. So these are the forces acting on the soil particles. This is important. Gravitation force proportional to mass and surface force proportional to surface area. Okay, so here our question is behavior of clay is governed by. Behavior of clay is governed by mass area, surface area and mass surface area friction. So in clay we can see surface force and the surface force is proportional to surface area. So behavior of clay is governed by surface area. Option C is the correct answer. Next is soils are derived from. Soils are derived from rocks. The rocks may be sedimentary, igneous or metamorphic. So any one of the above is the correct answer. Option D is the correct answer. The next question, soils which are found away from their place of origin. Soil which can see at the origin itself we can say residual soils, and if it is transported to a new location with the help of some agents we can say it as transported soil. Option B is the correct answer. Okay, next 18th question. The soil in which highest percentage montmorillonite mineral is present. In soil we can say montmorillonite is present in bentonite clay. Bentonite clay, high percentage of montmorillonite mineral is present. Black cotton soil is also contain montmorillonite but lesser than the percentage of bentonite. Then varved clay we know that it's a sedentary deposits of alternate layers of silt and clay. Then China clay, kaolin mainly composed of kaolinite. Next question, black cotton soils are residual soils, organic soils, ash soils, expansive soils. So black cotton soils are expansive soils and residual soils. Both are correct. Black cotton soils are we can say it is residual soils as well as it is an expansive soil. So next question, the term drift in soil formation relates to drift. Deposits made by glaciers, deposits formed by melting of glaciers, lateral movement of soil, fissures formed in lateritic rocks. So drift is deposits made by glaciers, option A. Next one, talus is the soil transported by gravitational force. Talus, gravitational force. Next question, which of the following name is related to soil engineering? Rankine's theory. Okay, so next question, who is considered to be the father of modern soil mechanics? Carl Tersagi. Okay, next question, the soil deposited at the bottom of the lake is known as lacustrine soil. Okay, D. Next question, the soil that originated from weathering action on the rocks like granite, basalt, trap, etc. These are called soils that originate from the weathering action on the rocks like granite, basalt, trap, etc. is called black soils. So here the answer is option C, black soil. Next question, alluvial soil. These are transported soil. Then laterite soils. These are formed by leaching action. Okay, next question, soil formed by the accumulation of decaying and chemically decomposed vegetable matter under conditions of excessive moisture is called. We studied residual soils and transported soils. Along with that, we studied warped clay, loamy soil. So we are going to study a new term that is called cumulose soil. So cumulose soil is the accumulation of decaying and chemically deposited vegetable matter under excessive moisture conditions. So cumulose soil we can explain as the accumulation of decaying and chemically deposited vegetable matter under excessive moisture condition. So example for cumulose soil we can say peat, muck and humus. These are the examples for cumulose soil. So cumulose soil is a soil formed by the decaying and chemically deposited vegetable matter under excessive moisture condition. Example peat, muck, humus. Okay. What is peat? We can say peat is fully decomposed organic matter. Fully decomposed organic matter is called peat. Muck, organic matters plus inorganic matters. Muck. Then humus is topsoil. It is the topsoil but partly decomposed organic matter. Topsoil with partly decomposed organic matter. So cumulose soil is called the decaying and chemically deposited vegetable matter. Example peat, humus, muck. Peat is fully decomposed organic matter. Humus is the topsoil but partly decomposed organic matter. Muck, organic and inorganic matter. Okay. So here the answer is cumulose soil. Soil formed by the accumulation of decaying and chemically deposited vegetable matter under excessive moisture condition. So here alluvial soil, the transported soil. by running water, aeolian by wind, colluvial soil by gravitational force. The next question, the soil transported by running water is called alluvial soil. Aeolian, wind, marine by seawater and lacustrine by the still water of lakes. Okay. Next question. Cohesionless soils are formed due to. Cohesionless soils are formed due to oxidation of rocks, leaching action of water on rocks, blowing of cold and hot wind, physical disintegration of rocks. So what will be the correct answer? 28th one. Physical disintegration of rocks. Cohesionless soil, that is sand, coarse-grained sand. Physical disintegration of rocks. Then next 29th question. Lavos is silty clay formed by the action of. Lavos is the silty clay formed by the action of wind. Option C is the correct answer, wind. And this is called collapsible soil. Okay. Next, mode of transportation for alluvial soil is generally water. Running water, option C. Next, most fertile soil is alluvial soil. Most fertile soil is alluvial soil. Okay, next question. Soils containing organic matter. They are spongy in nature, swell with decrease of moisture, shrink with increase of moisture content. None of these. Soil with organic matter. Here the answer is they are spongy nature. Soils with high organic matter content have a spongy structure. It is because of the presence of humus and other decomposed material. And this improves the ability to retain water and air. Okay. So we can say that soils containing organic matter. Soils containing organic matters, they have spongy nature. Why it has spongy nature is due to the presence of humus. Humus is the topsoil with partly decomposed organic matter. Presence of humus and other decomposed material. This is one reason, and because of these decomposed materials, their ability to retain water and air improves, and as a result, it improves the ability to retain air and water. This makes them less dense and more porous than mineral soils, and as a result, they have less dense and more porous than mineral soils. So these are coming under why these soil containing organic matters are spongy, because they have the presence of humus and other decomposed materials. They are spongy in nature and they have the ability to retain air and water. They are less dense and more porous. Okay. So here the answer is spongy in nature. Organic soils containing organic matters are spongy in nature because of the presence of humus and decomposed organic matters. The next question: if soil in the nature remains in place directly over the parent rock, it is called residual soil. C. Okay. Option C is the correct one. Next question: black cotton soil has high bearing capacity, gives bad appearance to building due to black color. They have negligible permeability, volumetric change with moisture. It undergoes large volumetric change with moisture. Black cotton soil. Black cotton soil contains large amount of montmorillonite. Because of that presence, it has high swelling, high shrinkage. So here the answer is it undergoes large volumetric change with moisture. The next question: among the three types of movements envisaged through mechanism of wind erosion, which of the following is responsible for transporting the maximum portion of the soil along the surface of the ground? Here the answer is saltation. Option A is the correct answer. Here we see three new terms: saltation, suspension and surface creep. Saltation means it's a process of wind erosion where soil particles are lifted and bounced along the surface of the ground. So saltation, we can say, this is a process of wind erosion where soil particles are lifted. They are lifted and bounce along the surface of the ground. These are called saltation, in which the soil particles are lifted and bounce along the surface of the ground. We can say the saltation. In this mechanism is responsible for transporting the maximum portion of soil during the wind erosion. About 50 to 70% of the total movement of the soil particles happen due to this saltation. Okay, and the particles involved in saltation are usually medium size and it move in short hops. Here the particles are lifted and bounced along the surface of the ground to a short hop only. And most of the maximum portion of the soil during wind erosion get transported is around 50 to 70%. Then next term is suspension. Suspension involves very fine. Here the size of the particle is medium sized particles get transported due to wind erosion in case of saltation. In case of suspension, very fine particles carried high in the air for long distance. Here it is very fine particles get carried very high in the air for a long distance, but in case of saltation, large amount of soils get transported to a short hop only. Here medium sized particles involved in saltation, very fine particles carried to a long distances by suspension. Then next is surface creep. Surface creep moves largest particles. It moves the largest particle along the surface by the impact of saltating particles. So these are the three terms. First is saltation, suspension, and the third one is surface creep. In case of saltation, it's a process of wind erosion where large amount of soils get lifted and bounced along the surface of the ground to a short hop. In case medium sized particles are involved in this saltation. Then next is suspension. Very fine particles get transported to a long distance and it is very high in the air. Then next one is surface creep. In this case, large sized particles get transported along the surface by the impact of saltating particles. So in our question it is given that which of the following is responsible for transporting maximum portion of the soil along the surface of the ground. Along the surface of the ground, maximum portion is for saltation, and for if it is maximum or largest sized particle along the surface of the ground, it is surface creep. If it is for fine grained, we can say suspension. Okay, this is not along the surface, this is high in the air for a long distance. So here saltation will come. Question: consider the following statements in the context of aeolian soils. First one, it is a soil has low density and low compressibility. The soil is deposited by wind. The soil has large permeability. So find correct of these statements. So we know the aeolian soil, these are the soil deposited by wind. The second option is correct. Then we say that aeolian soil, example for aeolian soil lavas, these are also called collapsible soil. In case of collapsible soil, we studied that they are the soils with low density, low low density, low bearing capacity and high compressibility, and the volume get changed by adding water also. So these are the main properties of aeolian soils. So we can say the soil has low density is correct. Low compressibility, not low compressibility, high compressibility. If the soil is low density with high compressibility, we can say that is aeolian soil. Then next is the soil has large permeability. Large permeability is also correct. So here the answer is 2 and 3. Option B is the correct one. Okay, I will explain one more time. We learned that the collapsible soil. We learn about collapsible soil. The collapsible soil, we say that it is the soil with low density and very low bearing capacity, but they have high compressibility. The same we applied here. The soil has low density and low compressibility is given as here, but that is wrong. High compressibility. Then we know that aeolian soil is a soil deposited by wind and they have large permeability also. So option 2 and 3 statements are correct. So here option B is the correct answer. Okay, next question. Acidic soils are reclaimed by leaching action of soil, using limestone as a soil amendment, using gypsum as a soil amendment, then provision of drainage. So acidic soils are reclaimed primarily by adding alkaline materials, like lime. So we can reclaim the acidic soils by adding alkaline materials like lime. So here the answer is using limestone as a soil amendment. Okay. Then next question. The collapsible soil is associated with. So collapsed soil is called, we can say, loose structured soil. So loose structured soil comes under aeolian soil. Okay. Next question. Consider the following statement. Peat and muck are organic soils. Peat is an inorganic soil, whereas muck is an organic soil. Indurated clay is a type of clay which does not soften under prolonged wetting. So which of the above statement is or are correct? So here let's take the first statement. Peat and muck are organic soils. That is correct. Peat and muck are organic soils. First option is correct. Second one, peat is an inorganic soil. Peat is fully decomposed organic soil. Peat is fully decomposed organic soil. Whereas muck is a combination of organic and inorganic soil. Peat is an organic soil. So this statement is wrong. Second one, indurated clay is a type of clay which does not soften under prolonged wetting. So what is indurated clay? Indurated clay is type of clay and it get hardened. Does not soften means it get hardened due to heat and pressure. So this is a correct statement. So indurated clay is a type of clay which does not soften under prolonged wetting. So statement 1 and 3 is correct. Option D is the answer. Next question. Consider the following statement. Knowledge about moisture content is necessary to determine permeability. Some typical marine clay may have moisture content as high as 400%. Sandbath method of moisture content determination is not suitable for soil containing organic matter. So in this case, here the statement 2 and 3 is correct. So the option 2 and 3, option C is the correct answer. This portion we will discuss in the next chapter. Okay, next question. Lacustrine soils are obtained from lacustrine stones, lake beds. So easy. We discussed this question so many times. Which of the following soils is transported by gravitational force? Gravitational force, talus. Laos is aeolian. Drift. Sand dune is also by wind. Drift glaciers. Okay, next, glacier soils are those which deposited in seawater, deposited at the bottom of the lakes, transported by running water, none of the above. Glacier soils are those which are deposited by glaciers. In seawater is marine soil, bottom of lakes, lacustrine soil, by running water, alluvial soil. None of the above is the correct answer. Next, loam is a mixture of loamy soil, also called garden soil, sand, silt and clay of almost same proportion. Okay, sand, silt and clay. Next, the swelling nature of black cotton soil is primarily due to the presence of montmorillonite. Montmorillonite have higher swelling, shrinkage and plasticity. Next, black cotton soil which exhibit high shrinkage and expansive qualities due to the presence of clay minerals of group called montmorillonite. Okay. The engineering of soil is not related to the construction of ropeways. Option B. Okay, next, the collapsible soil is associated with lavas. So many times we discuss collapsible soils. Okay. Next, the soil transported by wind is called alluvial soil is by running water, marine, seawater, lacustrine, lake. So by wind is aeolian soil. Option A. Option A. Okay. Next, the soil transported by flowing water is called alluvial soil. Aeolian wind, marine, seawater. Okay. Next, which of the following soil has the finest grains? Silt, sand, clay, fine sand. So here the answer is clay. Next, a geologic cycle for the formation of soil or geological cycle of the formation of soil. Here it includes different steps. First, the rocks get weathering of soil. Then sometimes it get transported to a new location. There it get deposit, then deposition, then upheaval. So these are the stages in the formation of soil. So first is weathering of rock, then get transported to a new location, there it get deposit and upheaval. So option D. Weathering, transportation, deposition and upheaval. Then next, which of the following shows the correct order of increasing surface areas of the given soil? So here the answer is sand, silt, clay, colloids. Option C. So this is the increasing surface area of the given soil. First is sand, next silt, next clay, then colloids. Next question, the dry soil transported by the gravitational force or by gravitational force, which soil is transported? Colluvial soil. Option B. Cautionless soil is, cohesive soil is clay. So cautionless soil, sand. Option B. Which of the soil is transported through wind? Through wind we say aeolian soil. So lavas. Okay. Next, soils are basically organic and inorganic materials. Soils are basically organic and inorganic materials. Next, presence of organic matter in soil makes it spongy in nature. Okay, we already discussed this question, spongy in nature. Then deposits directly made by the melting glaciers are known as So here the answer is drift. Black cotton soil contains large percentage of clay material, exhibits high compressibility. Both A and B are true. Option B is true. So black cotton soil contains large percentage of clay mineral and it exhibits high compressibility. Also option A and B are correct. Next question. Cautionless soils are formed by constant blowing of wind in the same direction, deposition in a delta region, physical disintegration of rocks, chemical weathering of rocks. Chemical weathering of rocks, fine grained soils with fine grained soil and cohesive soil is formed. For physical disintegration of soils, coarse grain and cohesionless soil. Non-cohesive or cohesionless soil is formed in physical disintegration, and case of chemical weathering, cohesive soil is formed. Okay, next, black cotton soil is unsuitable for foundation due to its low bearing capacity. Okay, next question. Dispersed type of soil structure is an arrangement comprising particles having. Okay, we will discuss this question later. So next, moving to the next question. Residual soils are formed by. We already see this question earlier. So glaciers, wind, water. None of this is the correct answer. Next one. Transporting and redepositing soils is done by. Water, gravity, glacier. All of this above is correct answer. Then next one. Pick up the clay soil group which does not swell when wet from the following. Montmorillonite group, high swelling and shrinkage. Elite also medium swelling and shrinkage. Then kaolinite have strong hydrogen bonding between the structured units and there is no swelling, no shrinkage and no plasticity. So here the answer is kaolinite. No swelling and no shrinkage. So A is the correct answer. Okay, one more question is remaining. Dispersed type of soil structure is an arrangement comprising particles having face-to-face or parallel orientation, edge-to-edge orientation, edge-to-face orientation, all of this. So we want to learn one more topic from this origin of soil, that is soil structures. Soil structures. So let's see the soil structures. Mainly 4 types. Okay, first is single grained structure. Single grained structure. This is mainly for gravel and coarse sand. Coarse sand. Single grained structure for gravel and coarse sand. Next one is honeycombed structure. Honeycomb structure. Honeycomb structure is for fine sand and silt. Fine sand and silt. Third one is flocculated structure. Flocculated structure, or we can say edge to face structure. Flocculated or edge to face structure. This is for undisturbed clay. And the fourth one is dispersed structure. Dispersed structure. This is face to face structure or dispersed structure. This is for disturbed clay or remolded clay. These are the 4 types of soil structures: soil grained structure, honeycomb structure, flocculated structure and dispersed structure. Single grain structure for gravel and coarse sand, honeycomb structure for fine sand and silt. Then is flocculated structure. Flocculated structure also called edge to face structure. This is for undisturbed clay. And for then last one is dispersed structure. Dispersed structure is for disturbed clay or remolded clay, that is called face to face structure. Okay, so next let's see that question. Okay, here the question is dispersed type of soil structure. Dispersed type of soil structure is an arrangement comprising of particles having dispersed type of structure for disturbed clay or remolded clay. Here we can see face to face orientation is also called parallel orientation. Face to face orientation or parallel orientation. Then next is edge to edge orientation, edge to face orientation. Edge to face orientation is called flocculated structure. Here that is for undisturbed clay. Okay, so thus we've covered almost all questions from the topics origin of soil. Hope you all like this video and understand the complete topics. If anything more regarding this topic, I will explain the next video. So thank you for watching.